Today in lesson 66, we are reading a centimeter scale. So here's some different examples of what you might see as far as like types of scales. Okay, what do these look like? Rulers. Yeah. So when you have like a regular ruler, you typically have like inches on one side and you have centimeters down on the other side. Some rulers don't have centimeters. Why do you think that's the case? Yeah. Why do you think? Yeah. We don't usually measure in centimeters. We don't usually use meters to measure length. We typically use inches and feet and yards because we like to be really confusing in the U.S., right? Yeah. We like to change it all up. Okay? So something to think about 2.5 centimeters is equal to 1 inch. So if you ever were to look at a ruler where you had inches on the top, centimeters on the bottom, you could see that about, not exactly, but about 2.5 centimeters is equal to 1 inch. So if that's the case, about how many centimeters would then be equal to 12 inches? How could I figure that out? Avon? Why'd your hand up?
I was going to say, are we recording?
Uh-huh.
Oops.
How could I figure that out? If I know that 1 inch is equal to about 2.5 centimeters, how could I figure out about how many centimeters are in 12? Yes.
15 centimeters?
How did you do that? Like, what are you doing to solve for that?
2.5, so
2.5.
I off the 0.5 and I went to 6 times and then I got 12 and then I added up 5 or 1.5 with half of 6 3 times.
Okay.
15.
Okay. Okay.
Right?
We're going to see. We're going to test it. We're going to work it out in just a second. Anybody else think they know? Or figure out a way how we could find out for sure? Yes?
It says you could, how to find out how long 12 inches is.
Mm-hmm.
You could do 2 times 5, 2.5 times 12.
You do 2.5 times 12. So just looking at that and knowing that 1 inch is 2.5 centimeters, then 12 inches has to be at least, it's going to have to be at least double 2.5, right? Because 2 times 12 is 24. So we're already looking at probably around 24 centimeters, but it's going to be more because it's 2.5 for every 1 inch. So if I were to multiply that out, I could break it up in a couple of different ways. Okay, first, if I wanted to multiply it with the standard algorithm, I would do 5 times 2 is 10, carry the 1, and that would be 6. Put my placeholder, and then add these together. And I would have 30. Okay, so 30 centimeters. I could also do it this way. I could do 12 times 2.5, and I can break it up. I can break up 12 and do 12 times 2. And then I can do 12 times 0.5. And then I can add those two partial products together, which is essentially the same thing that I just did right over here. I just combined it all in one problem. Yes?
You could add 2.5 times 2, and then it's 5, and then since 2.5 is half of 5, then you could narrow the 12 down to 6 and use that
Yeah.
multiplication.
Yeah, absolutely. There's lots of ways you can play around with numbers, which is what I think makes math so fun, because you can break apart numbers so many different ways. Yes? Yes. All right. Write the length of this segment. Y'all see this line segment that I'm talking about?
Yes.
Okay, it's right here. Okay, the length of this segment in millimeters would be about what?
24.
Here's the end of it. Is it all the way over here to 25?
No.
It's like right here at 24. Okay, so we're going to say A is approximately 24 millimeters. But for B, the number of centimeters, it's approximately
2 4/8.
ooh,
2 4/10.
2 4/10. Does everybody agree?
Yeah. It's also 2 2/5.
Yes, 4/10 is reduced to 2/5. So looking at this, notice that I have 10 little bitty lines. Here's the halfway mark. And then I have 1, 2, 3, 4, 5 more. So I have 10 lines in between here. So it's, if I'm stopping right here, that would be 4 out of 10, which is what Luke was saying. So it could be 2 and 4/10, but he also said it could be 2 and 2/5. Okay, those two amounts are the exact same amount. One of them is just simplified. Are there any questions on this one? Using a ruler, looking at that. Okay, here's an example on a number line. We want to name the fraction or the mixed number that each arrow is pointing to. So looking at this first one right here, okay, notice, okay, yeah. So I'm given decimals. I want to do fractions or mixed numbers. How would this fraction look if it's 0.6?
0 and 6 or just 6/10.
It would be 6/10. It would be 6/10 because I want to write a fraction for it. Can that be simplified? Yeah. Not at the moment. Could that be simplified to what? 3/5, right. What did we reduce by? We reduced 10. We divided each of them by 2, right? So that could be also named as 3/5. Both are the exact same amount, they just look different, okay? It's like if I were to have 2 fraction bars and I broke them each up, like I did one into fifths and I did one into tenths, and I shaded the exact same amount. So I did 5/10 here. Where am I? 5/10. And then 3/10. Or 6, I did 6/10, sorry. 6/10 and 3/5. It's the same exact amount, it just depends on how you're breaking up the denominator. Okay, let me erase that and get that out of the way. All right, the next one is 1.2. What does that look like as a mixed number? 1 and, how do I read that first? 1 and 2, what? Tenths. So how do I write that as a mixed number? 1 and 2/10, right?
Also
1 and 1/5 would also work. Okay, the next one would be 1 and 9/10. That can't be simplified. What about the next one? 2 and 3/10. Are y'all starting to see how this works? Okay, the way you read it as a decimal is how you write it as a fraction. Okay, we say 6/10 when we read this fraction. That's also how we read this decimal. They're read the exact same way, they just look a little different. To what decimal number is this arrow pointing? First, you need to figure out how many spaces are in between here.
Can you go the other way and simplify it and then subtract it?
Explain. What do you mean?
Go backwards.
Oh, like start at 10, but if you would have to know that there's 10 then, and then count back to 7. As long as you know how many is in that section, yes. Okay, Bryce.
3 7/10.
3 and 7/10. Okay, that's my mixed number, but what is my decimal? 3 and 7/10, right? You still say it the same way, but it looks like 3.7. Yes, very good. Okay, that's it for today. You've got like 5 bonus minutes today for your assignment. You can work with a partner today. But nope, don't move yet. Don't move yet because you need your paper.